So in our last video, we made the statement that the IMA equals the number of supporting strands. And I want to make a video sort of explaining exactly what this means and hopefully make this incredibly obvious how this works. And so let's draw a new system. Let's draw ourselves another roof. Let's say we're going to lift up a car. So let's draw ourselves a car. Here's the front. Draw out the roof, the back. Now let's make this a super small car, just so we can fit it all in our notebook. We draw the little holes for the wheels, and then we finish it off. We even draw our little wheels, so there's no doubt it's a car. And let's say it weighs 1,600 pounds. That's our force resistance, FR. And let's put some pulleys on it. Let's put one right here. Let's put a couple on the top, and then maybe one on the back. So we got several pulleys coming off the car, and then let's add several pulleys here to the roof. Let's put them in between each set of the green ones, the ones coming off the car. And let's add one more here off to the right, and you'll see why we set it up like this in just a second. But let's run a rope through it. So we tie the rope off here, and we run it through our system. So we bring it around each one, running it through each individual pulley. And as you can see, what this kind of does is it sort of divides the weight evenly between each one of these strands. Then here at the end, we'll have Mr. Anderson sort of pulling down and applying a force effort downwards. So FE. Well, if we count out the number of strands, how many strands do we have in total? That's 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 strands in total. But not all of these strands are supporting FR, and it's only these 8 that are supporting FR. This last one over here doesn't actually support FR, so it doesn't add to our mechanical advantage. And you might say, well, Mr. Anderson, how do I tell which ones are supporting strands? And you kind of look at it and you say, well, which ones are attached to the roof and supporting FR? So if I were to just get rid of the pulley system and just have those ropes attached straight to a roof here. So we were to just draw a roof, and each one of these are attached straight to the roof. Look which ones are actually attached to the roof and FR, and which one is just sort of pulling down on the roof. And you can see these 8 strands to the left are the only ones really holding up FR. And so looking at it this way, it's a lot easier to tell that there are only 8 supporting strands. And this makes the IMA equal to 8 because it's dividing the weight by these 8 strands. And this is what mechanical advantage does. It sort of divides our force into separate parts. So we actually only have a fixed pulley here at the end, fighting only a portion of our force resistance. And in fact, since it's divided equally between those 8 strands, it's actually just FR, our force resistance, divided by 8. Because that's the only strand that this force effort is having to mess with. It's the only one it has to deal with. Which sort of makes force effort 1/8 of the force resistance, which is 1,600. And so what's 1,600 divided by 8? Well, that's just 200. Which means our FE is equal to 200 pounds. And this is sort of what mechanical advantage does. It sort of divides our force into separate, smaller, equal forces. Or not separate equal forces, but it divides it into a smaller force by increasing this distance, which is kind of what's going on. And we call this system that we just drew, we call it a block and tackle. And all a block and tackle is fixed and movable pulleys working in combination. So fixed and movable pulleys in combination. And if you're wondering why they call it a block and tackle, let's go ahead and draw another quick example to hopefully explain that. So let's go ahead and give this two pulleys coming off the roof. And let's say we're going to lift up some FR. And let's say this FR is, let's go ahead and make it newtons this time. Let's make it 100 newtons. Because it doesn't have to be pounds. It works the same in the metric system. We could also make it kilograms, although kilograms isn't really a weight, just a number of atoms. But let's attach this to another pulley system. Let's go ahead and draw this pulley system as just a big rectangle here. Let's have one pulley here off to the right, slightly off to the right of this pink pulley, and then one right in the middle. And hopefully you'll see why we drew it this way in just a second. But let's tie off a rope here, and let's run it through this pulley system. And so we run it through each one here. And you can kind of see how it'll divide the force into separate equal strands. And then we'll pull down here. And let's pick the right color, but we'll pull down here with a force effort. And as you can see, I color-coded it. Well, I color-coded it to separate the difference because on the top, we have the block. And on the bottom here, this bottom pulley system, is the tackle. And so I'll go ahead and divide that out. And so on top, we have the block, which is just the series of fixed pulleys. And if you look, it's just a bunch of fixed pulleys. When we say fixed pulleys, we mean literally fixed, meaning they're not moving, they're held in place, in this case because it's on the roof. And let me actually make sure this underlining this word fixed is the right color. That's why we call it a block. It's not moving, it's just a block, it's fixed. And then the tackle is the movable series of pulleys, movable pulley series, attached to FR. So attached to FR. And when I say movable, I mean literally these pulleys are moving up. As I pull down on a force effort, this pulley system goes up. It's not like a challenge. You go ahead and solve, now that we've defined what a block and tackle is, see if you can pause the video and solve for force effort. And so hopefully you realize that even though there's 5 strands here, only 4 of them are supporting FE. So that means the IMA is equal to 4, which means the force effort will be 1/4 of our force resistance. And 100 divided by 4 is just 25 newtons in this case. And this is how a block and tackle works. And then one more thing I want to drive home over here. If we look back, you say, well, Mr. Anderson, is it always 1 strand less? Is the number of supporting strands always 1 strand less than the number of total strands? The answer is no. You kind of have to look at it and count it. Let me show you how I figured that out. If I were to take out this end and just make this last rope here, or this last strand pulling up with FE, well then this would be a supporting strand too because it's pulling up on my car, and now I'd have 8 strands in total and all 8 are supporting. So not necessarily. And so you do have to kind of look at it and think about it for a second to calculate the IMA of a pulley. But hopefully that makes calculating the IMA of a pulley easier. You just have to count the number of strands holding up your force resistance.